All right, college algebra students, time to investigate a topic on sequences. So we're going to talk about sequences and series in these next two lessons. And it says find the first four and then the 100th term of the following sequences. So this is a sequence, and this notation means that if you'd like to find the first term, which is referred to as a sub 1, then we plug 1 in for n. 1 minus 5 is 4. Negative 4, excuse me. If you'd like to find the second term, you take 2 minus 5, and you get negative 3. A sub 3 would be 3 minus 5, which is negative 2, and a sub 4 is 4 minus 5, which is negative 1. So if you look at these terms, negative 4, negative 3, negative 2, negative 1, can you predict the next term? And you can. As you look at that, you see that each one is increasing by a value of 1. So sequences have often these patterns that exist where they have predictability. Now, that's not always the case, but in this case, you can see you could really predict the next terms. They'd be 0, 1, 2, 3, 4, so on and so forth. What's nice about this sequence is it is explicit, meaning you can plug in a value for n, which would be 20, to find the 100th term. Excuse me, we're going to find the 100th term, not 20th term. The 100th term, we get 100 minus 5 is 95. So that's the 100th term. Look at the next one. If we find a sub 1, it's equal to 3 times 1 plus 1 squared. And 3 times 1 is 3 plus 1 squared. That'll give me a total of 4. A sub 2, I have 3 times 2 plus 2 squared, or 6 plus 4 is 10. A sub 3, right now maybe try to predict the next term. What's it going to be? Saw you went up by 6, maybe you think the next one's going to be 16. So we try 3 times 3 plus 3 squared, and I get 9 plus 9 is 18. So it's not 6, it's 18. If you look at a sub 4, we get 3 times 4 plus 4 squared. You get 12 plus 16 is 28. So look at what you have here. You go 4, 10, 18, 28. So you can see it went up by 6 there, then you went up by 8, then you went up by 10. And so you're right, this next one would go up by 12. That's the pattern here. A little bit difficult, though, to predict the 100th term unless you actually plug in 100. The 100th term would be 3 times 100 plus 100 squared. 100 squared is 10,000, so we get 10,300 is that term of the sequence. I don't want to do all of these, but we're going to do 2 more with you. And as we find the first term here, we get 3 over 5. And as you look at the second term, we get 6 over 6. The third term, we get 9 over 7. And the fourth term, we get, let's see here, 12 over 8, or 3 halves. So look at how difficult that is to think of. If you were to look at these terms, you would say, well, there's no relationship at all. It would be very difficult to suggest, what the next term is going to be. And it turns out there is a relationship. The relationship is shown right there, but the evidence of the terms is very difficult to understand. And so the 100th term, you can see, would be 300 over 104. I know both those are divisible by 4. If I divide by 4, I get 75 over 26. So that's the result. Yeah, kind of interesting. Tough to see the pattern with the numbers, but there is something existing there. The next one I'd like to show you, a sub 1, you would have 2 to the negative 1 power, which is a half. And then a sub 2, you'd have 2 to the 0 power, which is 1. And then a sub 3, that'll be 2 to the first power, which is 2. Then a sub 4 would be 2 to the second power, which is 4. What's happening each time? You go up by a half, then you go up by 1, you go up by 2. Really what's happening is each one is being doubled. And so a sub 100 would be 2 to the 98th, which is a very large number. But what's happening each time you're multiplying by 2 is what's happening. So let's focus our attention on 2 types of sequences. There's many sequences out there, many. But there are 2 that are most common. And the first one is referred to as an arithmetic sequence. The arithmetic sequence is a sequence whose consecutive terms have a constant difference, d. So, for example, -3, +1, +5, +9, 13, so on and so forth. You can see that there's a constant difference. The difference each time is 4. If you take any 2 consecutive terms and subtract the larger from the smaller, you can see that you do in fact come up with 4. Okay? And so in that situation, we say that that's arithmetic. You simply just add 4 to the previous term, you get the next one. The formula for an arithmetic sequence is a sub n is equal to your first term, a sub 1, plus the difference times n minus 1. And that is our formula. It says in this direction, find the nth term and the 20th term given the following. Our first term is 5 and the difference is 3. So if the difference is 3, then these would be your next terms, so on and so forth. So first of all, we have a sequence where we can produce the next terms. It would like us to find the nth term. A sub n is equal to the first term plus the difference times n minus 1. So the a sub nth term is 5 plus 3n minus 3, or a sub n is 2 plus 3n. Once we have the a sub nth term, it's easy to find the 20th term. A sub 20 is 2 plus 60, which is 62. In this example, you see your first term is 100, and the difference is -2, so therefore the next term would be 98, 96, 94, 92, so on and so forth. Well, the a sub nth term is going to be equal to the first term plus the difference times n minus 1. 100 minus 2n plus 2, or a sub n is 102 minus 2n. Now that we have the a sub nth term, we can get the a sub 20th term by plugging in 20 for n. And just by chance, you happen to get 62 again. What's different about these next 2 is they don't tell us the difference. We would need to state the difference. You can see I actually created this sequence earlier just by chance. You see that it increases by 4 each time. So your difference is 4. So a sub n is your first term plus the difference times n minus 1. So your a sub nth term is -3 plus 4n minus 4. Or a sub n is 4n minus 7. It also says to find the 20th term. If you plug in 20, you get 80 minus 7, which is 73. Sometimes you need to convert things to decimals in order to understand them better. 20, 19.5, 19, 18.5, so on and so forth. It looks like the difference is -0.5. So the a sub nth term is your first term plus -0.5 times n minus 1. Where a sub n is 20 minus 0.5n plus 0.5. A sub n is 20.5 minus 0.5n. So if you want to know the 20th term, plug in 20 for n 0.5 times 20 is 10, and so we get 10.5. The second type of sequence we want to talk about, and the last one for today, is the geometric sequence. Geometric sequence is a sequence whose consecutive terms have a constant ratio. And we're going to use R for constant ratio there. So what would that look like? Well, for example, if you had 1, 3, 9, 27, 81, that is a geometric sequence because you were multiplying each term by 3. The way we determine the a sub nth term of a geometric sequence, or the formula for a geometric sequence, is the first term times the ratio to the n minus 1 power. So let's first understand the sequence. It says the first term is 2 and the ratio is 3. If the ratio is 3, that means your next term is 6, then 18, and 54, and so on and so forth. So a sub n is equal to your first term times 3 to the n minus 1. And that's it. First term is 64. If the ratio is 1/2, then it would be 32, 16, 8, 4, so on and so forth. So your a sub nth term is equal to your first term times the ratio to the n minus 1 power. Here they don't give you the ratio. You can see that the ratio is 3. So a sub n is equal to your first term, which is 1, times your ratio, which is 3 to the n minus 1 power. Looks like we're dividing by 4 each time. So the ratio is 1/4. It also looks like we're switching between positive and negative. So therefore, it's a negative 1/4. The a sub nth term is negative 200 times negative 1/4 to the n minus 1 power. If you're ever wondering if you have the formula written correctly, just go ahead and plug in a term if you would like. Negative 200 times 1 divided by 4, and we're going to raise it to, use that caret key, and then parentheses, n minus 1. So this would be your first term, second term, third term. Let's check the third term. So 3 minus 1. And you should get negative 25 over 2, or negative 12.5, and sure enough you do. It's a good indication that you did it correctly. A little bit complicated here. You can see each time you're multiplying by the root of 3. So a sub n is equal to 1 times the root of 3 raised to the n minus 1 power. I'll do something a little bit different here. This would be fine to write it that way, but it is 3 to the 1/2 to the n minus 1. And if you do a power to a power, another way to write it would be a sub n is equal to 3 to the n minus 1 over 2. So these are all the same things there. And your last one, a sub n, is equal to your first term, which is 8, times your ratio. What is the ratio? Sometimes difficult to see. If you take any two terms and divide them, say negative 64 over 27, and we'll divide it by the previous one, 32 over 9. That should tell us what the ratio is. Yep, negative 2/3. If you're not convinced, try a different one. Parentheses, negative 16 over 3 divided by 8. And again, you get negative 2/3. So you can see that the ratio is negative 2 over 3. Maybe if you look at these, you could convince yourself that the ratio is negative 2/3 and you're multiplying each time by that. So we have negative 2 over 3, and we raise it to the n minus 1 power. Now produce any term that you want then. There you go. Geometric sequences. We'll see you soon.